Hi, my name is Ted.
Hi everybody, my name is Nobi.
I would like to go through Riso Digital Master Mesh selection today.
Okay, please.
Sure. First of all, Nobi, would you show the Riso Digital Screen Master?
Yes.
This is the Riso Digital Screen Master. To give you some inside look, it is a lamination of thin film and mesh. It is laminated together. And this film is heat sensitive. So when you add heat, perforations are made onto the film. And then when you apply ink, the ink will go through the perforations and will be printed. That is Riso Digital Screen Master.
So this master is already sticked, right?
Yes, it's laminated together.
Okay.
Having said that, I would like to go through the mesh selection to choose for fine prints or rough prints or full color prints.
Okay.
We have a wide variety of selections, but today I would like to talk about 100 mesh and 300 mesh, giving you an example. Like I told you earlier, the Screen Master is a lamination of film and mesh. The film part, even if you put ink on it, nothing will come out. But with the mesh part, if you apply ink, ink will come out from these holes.
So this part's already burned, right?
Right.
Okay.
So in this one, if you squeeze it, this triangle portion will be printed.
Okay.
This is the model of the squeezy, and I would like to use red ink to print. For example, like this. So the ink went through the mesh, so the triangle is printed. When you remove the mesh, it will look like this.
Okay.
Technically, it will look like this.
So it's like the actual result, right?
Right.
Okay.
100 mesh has a coarse result. 300 mesh, it has a finer result. Right. But this is technically how it looks like. But ink in the nature does exaggerate. So when you remove the film, the mesh, then the ink will start sticking, coming closer together. So it likes filling up the gap in between. So
Okay.
it will look like this.
Okay.
In reality. Also, like I said, ink comes close together, exaggerating. It happens at the edge as well. The ink is trying to move out from the perforated area.
Mm-hmm.
So you see, this edge, it has a rough line opposed to this 300 mesh.
This part, right?
Yeah, it has a fine line. So when you look at the real microscope photo of those printed materials, the left-hand side is 100 mesh, the right-hand side is 300 mesh. I'm using solvent ink on this one, on a matte film, and you see the edges like this on 100 mesh, it's rough.
Yes. And here is smooth, right?
Yes, it is smooth. Right.
Okay.
Okay. Right. That's what I meant to say with 100, the difference between 100 mesh and 300 mesh.
Okay.
Also, when you take a look at another thing with the solvent ink, this is for characters. You see these edges. Once again, it's rough and
this part is smooth, right?
yes, right. The other thing about the ink is the difference is coming from this. We call it ink deposit. The left-hand side is 100 mesh. Right-hand side is 300 mesh. This is one cutout, one hole for 100 mesh, and for 300 mesh to have the same size, you need.
So this size and this size are the same, right?
Right.
Okay.
You need 9 holes
Okay.
with the 300 mesh. So when you print it, in reality, and together, this size will be like this because smaller holes. Also, the thread is 54 microns for the 100 mesh.
And this is 34 micron, right?
Right.
Yes.
And you have 2 threads for one master. So that means this is the amount of ink deposited. So you've doubled it by this. It means roughly it has 100 microns. 100 microns worth of ink is coming out. And this is 60 microns worth of ink is coming out. So in reality, the ink deposit with the 300 mesh is roughly 60% of 100 mesh.
Okay.
Less ink than 100 mesh.
Okay.
That is the key point. Okay. So having said that, there's more ink on the 100 mesh, less ink on 300 mesh. You see this angled photograph of the same slide I've shown 2 slides ago. You see these humps, more ink is being deposited onto the image. And this one?
And this one you mean less ink, right?
Less ink
Okay.
on the image. This is happening.
Okay.
Right? So if you take another look when you print on cloth this time, last time it was on
Solvent ink, right? Yeah.
Solvent ink. This is using plastisol ink. Because of cloth has a nature to absorb ink, is absorbing more ink. So you see the edges, once again, it is rough compared to
And here is smoother.
smooth, right?
Okay.
And you see this line is narrower than this one.
It's a little bit wider.
Right.
Yeah.
That's the difference in between 100 mesh and 300 mesh.
Okay.
Okay. Once again, using plastisol ink on cloth, using the same characters. You see this one, it has a rough edge opposed to 300 mesh, and fine lines.
Fine lines, but it looks
Right.
like more ink on this part, right?
Yes, exactly.
Okay.
You see, this has, like I said, more ink on it. You see these white spots on this 300 mesh. That is the difference in between 100 mesh and 300 mesh.
Okay.
Up to this point, I've been presenting the theory of 100 mesh and 300 mesh. Now, I would like to ask Nobi to give you an example of the low mesh and high mesh. Nobi, please.
Thank you, Ted. So let me use this graph to show the ink and mesh count. You can see this graph like this. The higher the mesh count is, the higher the definition is. So look at this part here. Roughly saying, if you use plastisol water-based ink, they're mainly for the wear and clothes. And solid lines, half-tone dots, these part. And roughly saying around 100. You see to 100 around 200. And the water repellent synthetic fiber is also near 200. So roughly saying, if you use plastisol ink and water-based ink, you use about 100, 200 meshes. After this, I will show you some samples of this. And this part is for solvent ink and UV ink, mainly for signboard graphics, nameplate stickers, electronic circuit boards also. Of course, later I will show you examples. So first one, and this is 120 mesh plastisol ink. You can see what Ted have in his hands. You can see these parts here, the solid parts. So to get the solid parts, he's using 120 mesh, and the ink is plastisol ink. Maybe you can see it well, but you can see the result is very good. Thank you, Ted. I'll go to the next one. The next one is, you can see this is CMYK using 4 colors. And you can see the halftones expressed very well. To get these halftone expressed well, you use 200 mesh. And also, this is plastisol ink. So you can see the both sides. They're using both plastisol ink, but it depends on what kind of result you want. Even if they're a plastisol ink, you use different mesh counts. Okay, thank you, Ted. So next slide. Again, coming back to this slide. So I explained roughly about this wear and cloth part. And next, I'll explain about this part, the sign graphic boards to the electronic circuit boards. Okay, so next is here. You can see what Ted has. You can see the gold and white and red expressed very well. Yes, and this is using 200 mesh and solvent ink. And also, like these small name plates, you don't need to print a lot, but these also using 200 mesh solvent ink. And also another one, I'll show you. And you can see this is 4 colors, but this is a switchboard. You can see the details printed very well. And this is using over 250 mesh and same again solvent ink. And can you see this part? Do you know what this is?
It looks like a circuit board.
Exactly, yes. So for this part, this is a challenge use over 250 mesh printing these circuit boards. Yes. So roughly, I'll explain this again. So we have mesh from 70 to 300. The first machine is called Gokopro 100. 70, 120 mesh, 200 mesh. Only 3 types. And you can see here, designed for water basic and plastisol ink. Of course, you can need solvent ink a little bit, but mainly for plastisol and water based ink. This is the first machine. And the machines coming later from QS200, QS like this, we have 50 to 300. So it's spreading the type of ink you can use for cloth printing, water based ink, plastisol. And also the plates use a higher mesh like this, like 200 or 300. Of course, this is not for everything, but roughly saying you can choose like this. Yes. So I think you understood well. And lastly, if you want more details, please check our GokuPro forum. You can see more details, or if you have any questions, please click the contact us and then give us some questions. Okay?
Hey, thank you.
Thank you very much.
Thank you.
Thank you.
Bye now.
Bye.